Great. Okay, cool. So first, thank you all for showing interest in this class. Sean and I are both extremely honored to be given the chance to teach all of you. So when Sean and I originally began thinking about teaching this class last semester, we initially had the idea of just opening a small section, like discussion size, with 65 people, and we were like, this is a good size to teach different concepts in like software engineering that you might need to use. Little did we know that interest in the class would explode up to like 300 plus people. And yeah, we were like, extremely surprised by the amount of responses that we got on the forum. So yeah, thank you all for coming today, and we hope you enjoy this content. The second thing is enrollment will be on a randomized basis because there's so many people. So originally our room was for 65 people. We found a bigger room for around 135 people. But unfortunately, that doesn't fit everyone. As today we see we have around 140 people. So go ahead and fill out this form if you're here today. This is the enrollment form that we're going to use to base off of for randomization. After you fill out this form, we're going to randomize people tonight and send out ad codes for the people that were randomized or were randomly selected. Okay, let me just go ahead and pop this in the chat so that I don't have to stay on this slide. Yeah, I'll send out the ad codes by tonight. That's right. Sometime after the lecture. So that's the link in the chat. Okay, and today's agenda is going to be course overview, like what we'll be talking about, and we're going to be talking about the shell. I'll be sending out the ad codes tonight, like for enrollment to this class. Okay, yeah, so today we're going to be talking about course overview and the shell. Cool, so the first question that might come up very naturally is why do we want to learn about this content? Like, what's the motivation? Well, so the motivation to teach this class came about while Sean and I were TAing. So we saw that computers, as we know in class, are really great at doing tasks. Like, for example, in 61A, we learned that you can do for loops, you can use while loops, you can solve problems of like really crazy scales. But we always use computers to solve problems for us. We never use computers to help us solve problems more efficiently. And so that's what we're hoping to teach in this class. We want to teach all of you how to use computers to help you solve problems more efficiently by leveraging certain tools that you already know and tools that you don't necessarily know yet. So for example, we're going to be talking about the shell and how to use it more efficiently today. And in the future, we're going to build off of the shell and use different programs and different tools that you learn inside the shell. And the shell will be our primary means of interacting with our computer. Okay, so before we jump into the content, let's go ahead and introduce the people that are involved in teaching this course. So it's me, Sean, and Aaron. Live transcription, yeah. Let's go ahead and do this. Enable, okay, cool. So the people are me, Sean, and Aaron. Let's go ahead and introduce ourselves. So I'm Addison, I'm a fourth year studying CS Stats and Math, and I'm really interested in teaching this content. I've also been a TA for 61A for many semesters, and I'm really excited to be teaching this decal for the first time. Yeah, Sean, go ahead.
Hey all, I'm Sean. I'm a fourth year studying EECS, Cognitive Science and Applied Math. I was the TA for 61A for a while, then CS70, and now for 189. And I'm also super excited because sometimes I'm a boomer with these tools, and I feel like sometimes it takes too long to learn them. So hopefully we can help you jumpstart that. And I'll pass it off to Aaron, who is our TA.
Hello, I'm Aaron. I'm a second year student studying CS and hopefully math. And I really am interested in all the management that we learn a lot in this class. So I'm really excited to be able to help teach it.
Cool. Okay. Yeah. Thank you all for your introductions. Some logistical things before we move on. Office hours will be Thursdays, 4 to 5 p.m. in SOTA 411. This is like the alcove area in SOTA, if you've ever been there. Feel free to come ask us anything during those hours. We've used a lot of these tools for many years in the past, and so we'd love for you to come and pick our brains. For this week only, office hours will be online using this same link. but in the future, office hours will be in person in SOTA 411. Okay, let's go ahead and jump into the terminal. So yeah, today is going to be course overview and the shell. So let me go ahead and jump into this terminal session. Okay, so this is what the shell looks like. You might be really familiar with this if you've done things in 61A and other classes. You've definitely seen this before. So the shell is the language of the computer. It allows us to use tools that were built in and shipped with your system, and allows us to combine these tools in different ways to get different effects that we want with the system. So you might have heard of different shells before. Shells that you might have seen is, for example, PowerShell in Windows that you might have seen, or if you use Linux or Mac, you might have seen something like the Bash shell or the Z shell. For this class, we're going to be focusing on the Bash shell, so BASH, also known as the Born Again shell, because it's the most common shell, and it's what people generally see or people generally use. Most shells are generally like Bash compliant. And if you're not sure if you have a Bash shell yet, that's part of the homework. So don't be like too afraid if you don't have the Bash shell yet. That's part of the setting up process in homework 0. Okay, so this is the terminal that I have shared. Can you all see this screen? It should be like a blue screen. Am I sharing the wrong screen? You all see it? Okay, great. Yeah, so this thing on the left here is called the shell prompt. All of you have a different shell prompt probably. This is what my default Bash prompt looks like, and this is what my ZSH shell prompt looks like. So everyone probably has something different. Today I'll be using this Bash prompt because it's probably what most people have or something similar. Here we can see that this is my username, and then here we can see this is the current path that I'm at. I'll be explaining what the path is a little bit later, but for now you can just kind of think of the path as like your current directory. So something that you see in like, the Finder if you use Mac or like, Windows Explorer. This is like the path that you're currently at. So this is a folder that I have open. We're going to be talking about how to use this shell in just a little bit. And this is going to be the main textual interface that we have with our computer. Question in the chat is, should we follow you on your computer or on our terminal? If you have a terminal, feel free to follow along. Your output might be different from mine because I have folders and files that you don't have. But yeah, feel free to follow along if you want to. Okay, so let's go ahead and take a look at the shell. In the shell, it allows you to run programs such as date. So let's go ahead and take an example. This is a program that basically just prints out the current date in your local time. This is great. There are also programs that take in certain parameters. So for example, you might want to use the program echo. Echo basically takes in a string and it spits out exactly what it took in. So to pass in an argument to a program, you separate it by using a space. So here we saw date took no arguments and echo will take one argument. So we separate by using a space. We might say echo hello, and we see that our terminal will spit back hello. That's fantastic. But you might have realized that I said we separate arguments with the space, right? So we separate like this program name with the argument that it has with the space. So like, what if we want to do something like echo hello world, right? What if we wanted to do something like echo hello world? This probably won't work, right? Because there's a space between hello and world. Well, there's a simple solution to this, and it's called escaping the space. We can do something like this. Just do hello, and then backslash, and world. And basically what that does is it tells your shell that this space is supposed to be treated as just one space and passed to the program instead of being considered two separate arguments, like that. Another alternative is you can do something like hello and world with quotes. And single and double quotes both work. I see in the chat somebody said that it worked without a backslash. So that's correct. For hello in particular, it treats every argument as like, it concatenates the arguments. And it says, treat all of these as like one big argument. But for other programs, they don't necessarily do that, and they treat the argument separately. So these would be treated as separate arguments in programs in general. Yeah, and as Aaron said in chat, for example, try multiple spaces. That's a really great way to illustrate these things. Cool. Yeah, so this is an example of an argument to echo. And a natural question that comes up is, how does your computer decide or like figure out where these programs live? Like, for example, this date program or this echo program, where is it coming from? So there's a thing, actually I'm jumping ahead of myself. So these programs are all stored in your computer's file system. So they're stored somewhere on the disk in like one of these paths. The way that your shell figures out which program to run is through a thing called an environment variable. So an environment variable is simply a variable that was defined in your shell when your shell started up. It turns out that your shell contains a fully functional programming language that we'll get into a little bit later. But this programming language lets you define variables, it lets you do for loops, while loops, and all of that stuff. So you can do things like, for example, loop and keep running this program until it fails. And that's totally valid code in your shell. But back to the point, there is an environment variable that defines where everything, or all of the functions, or sorry, all of the programs live on your file system. And your shell basically looks through all of these folders until it finds the first program in that folder, and it uses that program and it executes it. And this is called the $path variable. So we can show that by doing this. Here we can see I echoed my path out, and basically these are all of the folders that my shell is going to go through to figure out where the date and the echo programs live. It might be a little bit tedious to go into each of these directories to figure out, which one actually contains date and which one contains echo. So the shell also has a built-in called which, and you can just type which date, for example, and we can see here I have my date living in this directory. For most people, I think the date will be in like user bin date. That's usually the place where it belongs, or /bin/date. But either way, you'll see a directory, and this is where your date program is. Just as proof, I can just copy this and paste it here, and I can run that, and we see we get the same output. Cool. This leads us to explain what a directory actually is. So here we see this is called an absolute directory. An absolute directory always starts with a slash, and the slash means start looking from the root of the file system. Basically what this says is it's saying I start from the root of the file system, I go into the run directory, and then I go into the current system directory, and then this SW directory, then the bin directory, and then lastly, I have a program date in that bin directory. In Linux and Mac, you'll see that everything starts from the slash. So everything has like a global mount, or not a global mount, but everything is mounted somewhere on your file system. Whereas on Windows, you'll see something like C:\\, and that's because they have a mount per partition. Okay, and also on Windows, you'll see like backslashes. Yeah, we're not going to be like going into Windows, so that's like an implementation detail that's not too important. Okay, so here we have this absolute path, and it turns out there's another way to address file paths on your system. You can either use an absolute path as we have here, or you can use a relative path. And the relative path is basically a way to say, to navigate to folders or programs based on where you currently are in your current directory. Let's go ahead and take a look at an example. We can use pwd, meaning print working directory, to see where we are in our file system. So here I see I'm in home Addison stuff CS198, which is this class. I can use cd to change my directory to other things. So for example, I can change it to cd/home. And if I print my working directory again, I see that I'm at home. Perfect. Now I can go back to this Addison, or I can go back to an Addison directory by doing cd and then Addison. And that lets me go into the Addison directory, or the home/Addison directory. Now you might have noticed that like my working directory here has this little substitution, or this little like, modification of the home/Addison. So it turns out there are special directories that you can use. And I'll list a few of them here. There's the dot directory, and that basically means my current working directory. So dot refers to a current working directory. The dot directory refers to my parent directory. So for example, if I'm currently in the Addison folder and I do cd dot, I can see that I'm still in the Addison folder. I can do cd dot, and then I can see that I'm at the home folder. So this cd dot means go to my parent directory. Then there's the tilde directory. This basically refers to your home directory. And so tilde for me would be /home/Addison. So for you, it's probably going to be /home/your username. And so if I go there, I can see that I'm at home/Addison. Okay, so that's the third one. And then there's one more. There's the dash directory. So the dash directory refers to the directory that you were previously at before you came to this directory. So for example, if I cd to /, I can see that I'm currently at /, and then I cd to /home/Addison, and then I print my working directory, we can see that I was at / and I'm now at /home/Addison. And to go back to /, I can just do cd dash. And then that lets me go back to the / directory. Right, so the dash basically is a placeholder, meaning go back to my previous directory. Okay, there are some questions in chat. Okay, I think everyone has the answers there. Okay, cool. So those are the 4 special directories. We have the dot, the home directory, and then the dash, meaning go back to previous directory. Okay, cool. So back to this absolute and relative. So here's an example where I used an absolute folder, and this just means to like go exactly to this folder instead of searching relatively from where I am. And an actual question is, when might I want to use an absolute folder versus a relative folder? So typically, if you're navigating around in your shell, it's just a matter of preference. It's typically easier to use relative folders when you're navigating around because you know where you need to go. If you're writing a script or a program that other people need to use on different computers, it's generally a better idea to use absolute folders and files, because that way the program will run regardless of where the script is living. But as you use this more and more, you get a feel for when you should use different things. Okay, great. Let's go ahead and move on. So let me go back to my CS198 folder. This is the folder where we use, or this is the folder where we run our whole website off of. So let's go ahead and show an example of a different command. I can use the ls command, meaning list, and it basically shows me everything that I have in my folder. I can also pass in a folder to ls, for example, ls ... and that tells me to list everything that I have in my parent folder. As you can see here, I just have a bunch of random stuff that I've accumulated over the years. I can also list something that lives inside a folder inside of my current folder. So I know that, for example, lessons is a folder that I have, and I can just go ahead and do ls lessons, and it'll show me everything that I have within that folder. Okay, and so a question might come up, which is, how do we know which arguments ls takes in? Well, most commands have this --help built in. And so if you just do ls --help, you'll see that you have this really, really long output that shows you how to use ls. So it says usage, ls takes in some options, and it takes in 0 or more options, followed by 0 or more files. We can see that these are all options that they take in. We can see that some of them are considered flags, where they're either like a binary option, for example, like -a is a flag, or we can see that some of them specify like a parameter that you can pass into it. See if I can find one that takes in parameters. I don't think I can find one that takes in parameters, but some flags take in parameters, and for those we call them options. So here, let's take a look at an option that's pretty interesting. Here we see that there's this -l option, and it says use a long listing format. Well, let's go ahead and see what that does. So I can just do ls-l in my current working directory, and boom, we see, oh, it basically just lists everything that I have in my directory with a lot more information. And I guess that's why they call it a long listing format. Let's go ahead and break this down, because you're going to be using this command a lot, especially for this homework. So when you do ls-l, you basically get this output to the left. Then you get like this information here, followed by your actual file. So let's go ahead and break down what this means. On the very left here, we see we have this thing that's either a dash or a D. If we have a D, that means that the current thing we're looking at is a directory. So for example, we see this about.md uses a dash, meaning it's not a directory. On the other hand, this _announcements, it does have a D, so it's considered a directory or a folder. Then we see we have this like RWX followed by another set of RWX followed by another set of RWX. So these are what are considered permissions in Linux terms. So the permissions of this announcements file is basically these 3 groups of 3 combined together. Let's go ahead and break down what that means. The first group of 3 is the permission for the owner of the file. So the owner of the file, as we can see, is the person in this column. So the owner of the announcement folder is me, Addison. And I basically have read, write, and execute permissions. So the read permission for a file means that I can open up the file for reading. The write for a file means that I can write to the file and I can change its contents. And the execute means I can run it as a program. This second set is the permissions for a group. So the group is this column right here. So the group that owns this file is the user's group. And they have the permission to read. They cannot write because it has a dash and not a W, and they can read. Lastly, if you're not the owner and you're not within the group, you have these default permissions for everyone. And so the default permissions for this file is read and execute and no writing. So that's what these 3 groups of 3 mean. Once again, it's for the owner of the group, for the owner of the file, and then the group owner of the file, and then everyone else, which is this last one. Okay, something that should be noted is these permissions are slightly different for directories. So these permissions make a lot of sense for files, but for directories, it doesn't entirely make a lot of sense for you to execute a folder, right? So they mean something slightly different. R means that you can list everything within the folder. So you can run ls in that folder and it'll work for you. Write means you can create, rename, and remove things within a folder. In particular, this means that if you have a file and you don't have write permissions, you can't actually delete that file. That surprises a lot of people. The last one is X. It doesn't make much sense to execute a folder. Instead, what it means is it's called the search flag. And the search flag allows you to enter a directory. So for example, if I'm in like this folder right here, in order for me to actually cd to this directory, that means that I had to have the X permission on every single directory before that, because I need to enter every single one of those directories. Okay, I see some questions in the chat. Okay, I think that's been resolved. Okay, cool. If you have any other questions about like any other bits that might come up, feel free to come ask us in office hours. They usually mean it's a different kind of file, and they don't come up too often, so it's not too important. So other commands that might be useful if you have some files that you might need to move around is the mv command, which basically allows you to move something. So for example, if I wanted to move my license and I want to call it like license.new, I can just call it, or I can just do move license to license.new. And now when I list again, I can see that the license is gone and now I have license.new. And I can do this again to move it back, license.new, license, and I can see that I moved it back to license. Okay, another command that's useful is the copy command, cp. So the copy command allows us to copy files from one place to another. So for example, I can copy the license to license.new, and I can see that now I have both license and license.new. Right, so move allows us to move things, copy allows us to duplicate things. The last command that we want to go, or not the last command, but another command that we want to go over is remove. So here I created license.new. Maybe I don't want it anymore. So I can just do rm, which stands for remove, and I can do remove license.new, and it allows us to get rid of it, as shown here, where we don't have license.new anymore. Okay, other commands that are useful. It might be, it's important to note that remove doesn't let you remove folders by default. You need to use the recursive command -r to remove folders and things that are inside it. So things that work with folders, you can do makedir to create a folder. So I can just do makedir hello. And then if I list here, I can see that I have a folder, and I can see that it's a folder because it says D here. I have a folder called hello. If I want to remove a folder, I can just do rmdir. That means remove directory, and that allows me to remove that folder. It's important to note that rmdir will fail unless the folder is empty. And that's like the safety feature of Linux by default. If there's something inside the folder, it's going to get mad and say, hey, you have something inside there, it's not safe to remove. You should deal with that first before you come back and remove the directory. There is a way to force a removal, even if you have something in there. Feel free to read around the help pages to figure that out. But yeah, here I can see that hello is gone from here. Okay. Yeah, so what I did before with ls, this ls-help, you might have noticed it's kind of unwieldy, right? It just scrolls past and everything's gone. There's another way to actually see all the flags of ls. So I can do man, meaning manual, and then ls. So this allows us to see the man pages of ls. So here, oh, my man pages is messed up. Let me do something slightly different. I have something different that loads the man pages. But yeah, here we can see that ls allows us to list directory contents. And this allows us to you to scroll down and scroll up and see everything in here. To quit this, you can just type Q and quit the man pages. And this will be like your best friend when you have to learn new commands in the future. So for this class, if we tell you a command and you get confused, go straight to the man pages. It'll probably be in there. So yeah, for example, man date, you can see, oh, I forgot my man pages, I messed up. You can see all of the date commands, and it turns out you can write out like a bunch of different ways in the date. Yeah, so this will be your best friend in this class, and we encourage you to use it a lot. The real power of the shell comes in being able to combine programs to do like different things. So there are two primary streams that a program takes in. So there's the input stream and the output stream. The input stream comes in from the terminal, and it comes in straight from your keyboard. This is what we call like the input stream. The output stream is directly what's written in your terminal, and that's like the default program output stream. It turns out your terminal shell allows you to change these streams to do different things. If you're interested in this stuff, I recommend you to take sp22. You actually make a shell yourself and do all of this terminal redirection. It's really fun once you take this class and know what's going on. But yeah, you can leverage the power of streams to do crazy things. So for example, you can redirect the input of a stream by doing this thing right here. Basically, this is saying, I want my program to read in the file called file and set that as the input stream. Or I can do something like this, where I can redirect the output of the stream directly into the file called file. And I see someone is, oh, okay. So I would recommend you just to use mandate. So just use this command. I did the piping to less because my terminal is messed up a little bit, but I would just recommend you to use that. Anyways, back to this. So yeah, this allows you to redirect the input stream to file contents. And this thing right here lets you redirect the output of a program to a file right here. Okay, so let's go ahead and take a look at an example. So previously we showed that echo hello will print out hello to our terminal. Maybe I want this output to be redirected into a file. So I can do something like this, echo hello to hello.txt. After I do this, I'll see that hello.txt is a new file that's written on my system. And I can get the contents of this file by using cat. Cat is a program that by default takes in a file name and prints out everything in that file. So I can just do a cat hello.txt, and I can see, indeed, I do have the contents hello inside this file. On the other hand, I might want to do something like this. I might want to echo the contents of an entire file. So I can do that by doing this redirection, by saying read in using the shell all of the contents of hello.txt and feed that into echo as one command. Oops. So I have, oh, sorry, I meant cat hello.txt. So cat will read in like the contents of your input stream and print everything out, not echo. Yeah, so here we have cat, and it'll read in the contents of hello.txt, feed it into the primary input stream, and cat will print out that input. Cat will print out that input stream to the output stream, which is your shell right here. Okay, so this allows us to do something pretty cool. For example, I can copy the contents of hello.txt using cat to a new file. So for example, I can do cat, and then I can input hello.txt, and then I can output that to hello2.txt. And here we can see that hello2.txt contains hello as well. So what I did here to recap is I told the shell, read in hello.txt and use that as the input stream to cat, and then cat will basically take that input stream and then redirect it to the output. So copy everything over to the output stream, and then the shell will save that output stream to the hello2.txt file. Right, so this basically does that. So let's think about, or let's go ahead and see what happens. If I run this twice, I see that hello2.txt was overwritten. So like I ran this twice, but hello2.txt still had the same contents. And this shows that this redirection basically overwrites whatever was there. If I instead wanted to append things, I have to use the double right bracket or double right angle bracket. And that allows us to append to the end of hello2.txt. So now when I do cat hello2.txt, I see hello, hello. Yeah. Cool. So this one thing basically creates a new file or overwrites the file, and this two angle bracket will append to the end of a file. Cool. The last thing that we'll cover today is, well, yeah, the last like concept that we'll cover today is the pipe command, or the pipe like thing in a shell. So basically what pipe does is it allows us to send the output of a command directly to the input of another command. So for example, previously we did ls-l. This gave us a bunch of lines of output, but maybe we don't care about all of these lines. Maybe we only care about like the first line, which told us how many things we had in total. So to do that, I can do something like, I can pipe it into another command that gives me just that first line. So there's a command in Linux called head, and head will just give me the first n lines of an output. So here I have -n1, which means I only want one line of my input stream. And so here we see typing the result of ls-l into head just gave me directly this first line within this output stream. And you can imagine this might be pretty powerful, right? You can use piping arbitrarily to take outputs of one program, pipe it into another program, and the programs don't even have to be built for each other. They can just be programs that take in particular inputs and produce particular other outputs, and you can just use them to pass different things to each other. I could even pass this to another thing just to isolate this 144. So for example, I can do cut --delimiter equal to empty space. Basically what I'm doing here is I'm saying I want to take this output stream, cut it up by these spaces, and then take this the second field. And this will give me just this 144. And so you can see this is pretty powerful in general. Okay. Alternatively, I can also pipe this directly into another output file, and I can just say num things. And then if I just do cat num things, I can see indeed I have that 144 inside my file. Okay, so once again, this pipe allows me to pipe the output of some command into the input of some other command. And so here what I'm doing is I'm saying, I want to pipe the output of ls-l into the input of head, and then I want to pipe the output of head into the input of this thing right here, this cut command. And then I want to take that output and write it to num things. And all of this is done by using the shell. So the shell is doing all of the coordination here. Okay, so there's lots of cool things you can do here. So here's an example that's pretty contrived, but it's a cool example of what you can do. So there's a program called curl, and curl basically allows you to make an HTTP request to any link or any website that exists. So here what I'm doing is I want to get the HTTP header of the website google.com, and I want to grep for the content link. So basically what this is it's content link. Let me see if this shows up. Maybe it's content dash link. Okay, here we go. So what this is it's like how long that particular blob response is. And I can grab just this 219 by doing cut dash dash delimiter equals space, and then get the second field, and I can say 219. So we can see that this can be pretty powerful if we can just chain it with different things. This can be done in general for different streams of data, not necessarily just text. So there are particular programs that operate, for example, on image data or on streams of data, on video data, stuff like that. And you can generalize this to pretty much like anything that has just data within it. Yeah, so up to this point, let's go ahead and take some questions. Are there any questions in the chat that you two feel like we should address?
There's one question that I think might be better verbally, which is how often do people actually use shell like this? I feel like the command can quickly become really messy. So if you want to provide some like motivation maybe for like why we're learning this.
Yeah, Sean or Aaron, do either of you want to take this?
I could take it. Oh,
go for it. Go.
So I'll, for example, the shell is really common and it's really helpful for navigating the system and really quickly reading files and everything like that, because in the shell, you could often process data and just like wrangle it faster than you could do with like something like opening it in Excel.
Yeah, so I have an example of where I used this a lot last summer. So last summer, I worked at a company that had like huge amounts of data, and the data didn't like, you can't possibly load the data into some program all at once. Like there's just so much data that it actually doesn't fit in your memory. And so at that point, you kind of have to use the shell to like figure out which parts of the data you want to cut out, which parts you want to chop, and which parts are actually useful. So that's a pretty contrived example, I guess, but it's an example of where the shell really like shines and makes a huge difference. Yeah, I've used the shell a lot, pretty much like all throughout my like computer science degree. So it's pretty useful. Yeah, Sean, do you have a response?
Yeah, not much more to add there. I think that's great. One thing I think is there's like complicated ways to use the shell in bash script, and those can get very hard and very like knotted very quickly. But another thing is just sort of having fluency with it and getting practice with it allows a lot of everyday operations to become a lot faster. So instead of setting up a complicated program, you just have things ready. So I think it's really useful as a tool to just sort of be fluent like the back of your hand, and it'll just make everyday operations a lot faster for you.
Yeah, one thing I would add is we don't actually type out all of these on the regular. So there are a lot of programs that simplify your life. So for example, you probably notice that my shell looks really different, and there's a lot of things that you can do to make your life easier. Like I guess there's nothing in here. So for example, here I have a script that will just load up all the files that I have and lets me like search through them really fast. I think I'm lagging. Okay, yeah, it allows me to search through them really fast. But the point is like there's a lot of simpler ways to do things that that exist. Yeah. Okay, but for the introduction, we have to go through the hard way to get to the easy way, I guess. Okay, so let's go to a little bit, let's go to a topic that's a little bit more advanced. So in your computer, there's a notion of a root user. So far, everything that I've showed you was with this Addison user. In Unix and Linux, there's a concept of like a super user, or somebody that has access to do literally everything on the system. And that access is usually called root. So for example, if I go to cd/ and I do the ls-l, I can see that everything here is owned by the root user. So they basically can just do whatever they want on the system. So you might have seen, if you've ever done any classes or whatever, you might have seen this concept of like a sudo. You do something like sudo blah, blah, blah. And if you've ever copied and pasted commands, that usually just fixes your problems, right? It's just like sudo something and boom, all the problems are fixed. So let's go ahead and think about or like figure out what sudo is actually doing. So sudo, it actually means do as su, where su means super user. So what it's doing is it's saying run my command here as the super user. And the command that's passed in will be run as the root user. And so that usually like will fix whatever problems that you might have. So there are pretty legitimate use cases for this. And for this, I will go into my laptop because let's see if my laptop is up. Yes, my laptop is up because there's a pretty cool example of this. So I'm just going to go into sys. If you go into sys, you can see that there's a lot of different things that live under the sys folder. So in Linux, the sys folder is basically a way for you to interact with the Linux kernel itself. And it allows you to write to and read from parameters that are set by like things in the kernel. So for example, things in hardware, like your battery or your lights, you can all read and write to them as files, and it'll reflect real life. So one really cool thing that we can do is we can go into class, check the stuff here, and there's one thing called backlight. Let me see if I can find it. Backlight. And so we can go into backlight. And on my laptop, I have this Intel backlight here. And I can see that the brightness of my laptop is 17,000. And the max brightness of my laptop is 332,000 right here. So we can see that there's a brightness and there's a max brightness. And so it turns out you can actually just change the brightness of your computer by directly writing to this brightness file. So for example, you might think, okay, well, if I want to do that, I can just do echo like we learned earlier, and we can just do echo 16,000 and put that into brightness. But we run into this issue, permission denied brightness. Okay, so what's going on here is if we look at all the files here, we see that they're all owned by root. And so that means that as my current user, Addison, I don't have permission to write into this brightness file. And so I need more permissions to do it. I need the super user permission. So one way that you might have seen is I can just do sudo su, which means change my user to the root user. And then I have like super permissions, and that allows me to write into the files. Let me cancel this. But let's not do that. Changing your user to su is pretty dangerous, and it's very easy to nuke your drive and like, you know, render your system inoperable. So let's think about a different way to do this. So let me just go ahead and copy this here. Another way we might think of doing this is doing like sudo echo, right? Like we might think, okay, well, if I can't write into the brightness file, maybe the root user can write into the file. So I can do like sudo echo so that I'm running the echo command as the root user. Let's see what happens. Again, I get permission denied. So what's happening here? Why is it not letting me do that? Well, the reason it's not letting me do this is because this write bracket here, this redirect, is being done by the shell itself. So what's going on is the shell is saying, okay, run the echo command as root. But once you get the output of this, we redirect using the shell itself, and the shell is the one that's doing the writing to brightness. So when we get the output, like echo is being run as root, but when we're writing to this, brightness is being done as the current user. So that's being done by me. And that's why it's getting permission denied again. How did I display in my input history? You can ask me that in office hours. It's not built into the shell. It's some other stuff that I have. Okay, so yeah, so this redirection is being done by the root or by the default user, so by me, and so that's why it's not working. We can fix this by using the t command. So there is a command called t, and basically how that looks is we can do something like this. We can echo this output, if I can type, and we can do sudo t brightness. And what that does is it lets us take this output, and t says write into this file and also output it into the terminal output. So t takes in its input, puts it into the file that's listed, so this brightness file, and it prints it out again. So I do that. put in my password again, and boom, we see this is printed. If we do cat brightness again, we see that indeed it's been changed. And I see on my laptop that it's changed. So maybe I can show this a little bit more clearly. I don't know if this is like a very good demo, because I don't know if it's very easy to see. But okay, so here we're going to try this. We're going to see if this works. Okay, so here I have this brightness. I'm going to try to change it. What was my max brightness again? Max brightness. I'm going to try to change it to something like 25,000. Let's see what happens. Okay, I hope you all noticed that there was a significant change in my monitor's brightness. So here we can do this again. I can change it to a lower brightness, and we see that it got dimmer. Okay, so again, what we did was we took, oh, I turned off my laptop. I shouldn't do that. Okay, so what we did was we took the output of echo, and we used sudo to take the output of echo and pass it into this program that now runs as root, and that program will write into the brightness file, and it'll also spit out the value that was just given to it. So it allows us to change this file by reading the input and putting it in there with sudo. Okay, cool. The last thing that we will go over today is, so everything that you've gone over so far allows you to like interact with the file system and pretty much do nearly everything that you can that you would be able to if you use like Finder or Windows Explorer. The one thing that you're not able to do just yet is open a file. Like for example, if you have an HTML file and you wanted to view it in Google Chrome or something, or a PDF file that you wanted to open in like Acrobat. The way that we can do this is using XDG Open. So XDG Open takes in a parameter, so you can pass in like a file name, and it'll just happily open that file using your system's default like program for that file. So you can do, for example, XDG Open my file.pdf, and if you hit enter, your PDF should just open as default. Once you know this, you should be able to replace your like folder or your what is it called, like Apple Finder or Windows folders or whatever, with just the shell itself, and you should be able to open things through the shell. It's a pretty good exercise to familiarize yourself with this. Yeah, so that pretty much concludes the lecture on shells. Everything in the future will be based on this stuff here. So we'll be talking about shell scripting pretty soon. And in the next class, we'll be talking about like for and while loops and other things like that in the shell. Cool. So yeah, that concludes the lecture. So I'll stop recording here and I'll take questions as they come.